Describe the end behavior in limit notation. Well, what I have here is I have a negative 3x to the sixth, and that is my leading term. So two things that we're going to look at. I'm not going to draw this picture as accurately as humanly possible. This is what I know. This is an x to the sixth power. An x to the sixth power is an even degree polynomial, which means the way it opens up is the way it ends. But since this is a negative 3x to the sixth, that means it starts from the bottom, like Drake, and then goes up, makes a few bumps, and ends at the bottom. So I don't know what's happening in the middle here, but who cares? All I know is it looks like that or something like that. That's how it ends. We only care about the end behavior. So the way we write out the left side of the end behavior is as we move to the left, this is going downward. So another way of saying move to the left in limit notation is the limit as x approaches negative infinity. Now we're talking about g of x, so I'll say of g of x. Since we are going downward, as x moves to the left, we're going downward, we are going to say that my limit as x approaches negative infinity of g of x is also negative infinity because we're going down. Just like Fall Out Boy. Remember that song? Very old song. Now, as I move to the right, I'm going to word that as the limit as x approaches positive infinity. And what's happening to g of x as I do that? Well, I'm also going down, which means I'm also heading towards negative infinity. All right, so the trick is you look at your leading term. You look at if it's positive or negative, and you look at if it's even or odd. And since this is even, negative leading coefficient, we go down, both of them are negative infinity. Funzo.